So 7-5 is all about solving equations. So we've dealt with multiplying, we've dealt with dividing and adding and subtracting and even just simplifying. But now we're going to involve our equal sign and how to deal with that. And there's a couple of methods that we can use, but really if you have two fractions set to each other that are, set to each other with an equal sign, then we are actually able to do a shortcut, which is very nice. And that shortcut is something we've already learned, and it's called cross multiplication. So I'm going to cross multiply here, and I'll get 3 times 4x plus 5 is equal to 9 times x plus 1. I have the distributive property on the left and on the right. So that'll give me 12x plus 15 is equal to 9x plus 9. At this point, I need to make sure that x is on one side and the numbers are on the other. It's always easier to move the smaller x, so I'm just going to move that one. Your teacher may prefer you always move it on the left, but I don't really care personally. We get 3x plus 15 equals 9. And now I need to subtract the 15. I'll get 3x is equal to negative 6, and the final step is to divide by the 3. And we get the answer of x equals negative 2. And that's our answer. So it's a very simple and straightforward process. So let's do one more just to make sure we've got it under our belt. Example 1.1a has our same setup, so we're just going to go ahead and multiply. This will say 3 times x minus 7 is equal to 2 times 5x. Distributive property gives me 3 minus 21 is equal to 10x. This time, my smaller x is on the left-hand side, so I'm going to move it to the right and get negative 21 is equal to 7x. All right, let's divide by that 7 right there, and this time I get the answer of x equals negative 3. So far, very straightforward. All right, so let's have one that's slightly different. Let's go down to letter C on the left-hand side. Again, we're going to do our cross multiplication. It'll be 1 times 11x plus 8 is equal to x times 2x plus 5. Do the distributive property, we get 11x plus 8, because anything times 1 is itself, and this will just be 2x squared plus 5x. Now we have x squared to deal with. So anytime you have x squared, you want to keep x squared where it's at if it's positive, in this case it is, and bring everything else over there. So I'm going to subtract this 11x to bring it over to where the x squared is, and I'm going to subtract the 8. So it cancels out on the left, which is great, and I get 0 equals 2x squared minus 6x minus 8. And now I have a trinomial. I can actually factor out a GCF right here, and I'll get x squared minus 3x minus 4. If I look at just my trinomial inside of the parentheses, I can see I don't have to do the slide and divide method. I can just go ahead and factor like normal. So I'm just going to make a little bit more room, really. And I'm going to factor this, and I'll get 0 equals 2 times x minus 4x plus 1. However, these are not solutions. These are actually what we call factors. There's things that multiply together. So to get my solutions, what I'm supposed to do is set each one equal to 0 and figure out what x equals. X plus 1 equals 0. So it's a little cramped, but just bear with me. Obviously, this one, there is no x, so we can actually just cross it out. We don't really care. This one, I would add 4, and I would get this one is x equals 4. And then, of course, with that next one, I would get negative 1. And so this is our answer. In reality, we have to plug this 4 and this negative 1 back in to figure out if they're extraneous or not. But for this example, we're just going to trust it. And plus, I already checked it. It does work. All right, on the right-hand side, we're actually going to go to letter B, because, again, it's the same idea, but I just want to make sure that we've got this portion down, if you will. So again, cross multiplication, I'm going to have x, let's say equals, x times x minus 1 equals 2x plus 7 times x minus 5. Now I have, well, a whole lot. The left-hand side is just the distributive property, so x squared minus x. No big deal. But the right-hand side is actually, again, going to be FOIL. So I'm going to do my first. That'll give me 2x squared. Outside gives me negative 10x. Inside gives me positive 7x. And then the last gives me negative 35. I can combine my like terms right here. So I'm going to carry this part down because I haven't really dealt with it yet. And I'm going to get a positive 3x minus 35. All right, now I have x squared on both sides. Again, you should always, wherever it's positive, you want to keep it. But since it's on both sides, I'm actually going to move the smaller one over to the larger one. My smaller one is this one. So what I do to one side, do to the other, it cancels out. And since I'm moving everything on that side, I need to move the x as well. So it cancels out over there, and I end up with 0 is equal to x squared plus 4x. Oh, sorry. When I combined the negative 10 and the positive 7, I was actually supposed to make this a negative 3. So really, they're subtracting. So this is actually going to say a negative, let me make it negative, negative 2x minus 35. Okay, there we go. And we keep going. So to be 0 equals, I factor this and I get x minus 7, x plus 5. And so my answers are going to be x equals positive 7 and negative 5. And this is our answer. And again, they do both work out, so we don't have to worry about that. All right, the letter C beneath it, we didn't really, I did it in a couple classes, but I just want to make sure that if you are watching the video or you have an example like this on your homework, you're not confused, and hopefully this video will help you. We are doing that 2 times x squared minus 3 is equal to x plus 2 times x minus 3. We have the distributive property, that part hasn't changed, and we have foiling on the right. And I'm going to just do that really fast. We should get x squared minus x minus 6. Okay, again, we have x squared on both sides, so we need to actually move this x squared and everything else on this side to the other. So I'm going to subtract that. I'm going to add this, which it doesn't actually have a like term, so I'm going to put it in front, plus 6 plus 6. So everything cancels out on the right-hand side. On the left-hand side, I actually have the 6's cancel out as well. So I'm left with 2 minus 1, which is just x squared, plus x, because I put it in standard form. I just put it towards the end, and equals 0. I factor out my GCF because I cannot do my x factor this time, and I get x plus 1 equals 0. Well, again, each piece is set equal to 0, and this is why I wanted to show this. Each piece is set equal to 0, and so because I can't do anything with this, 0 is one of my answers, but so is negative 1. All right, so I just wanted to make sure that we saw that so we're not like freaking out. So what if you don't have, well, one fraction equaling one fraction? What if you have more than that? And that is when you have to use the method of using your LCD. It is the same exact idea as having your LCM, and many people will say, okay, we'll figure out what your LCM is and then multiply each fraction by that, but it doesn't really matter. You can do that method or you can do the method that we did in class. It doesn't really matter, but basically if you think about the LCD being the same thing as your LCM, just doing something slightly different, then you'll understand that they're the same thing. So I need to make my fractions have the same denominator in order to combine them. So I'm going to multiply my first fraction by 4. I do the bottom, I do the top. I do the same thing with that last fraction because it's also missing the 4. And in the center, I don't have the x. So this is going to say 4 times 5, which is 20, plus 7x over 4x is equal to, carried that equal sign down, negative 36, a lot of people miss this negative right here, negative 36 over, again, 4x. Now, if I wanted to, I could do cross multiplication, but I have something slightly different than what I had in example 1, and that is my denominators are exactly the same. And since they're the same, I can actually take this and just solve. 20 plus 7x is equal to negative 36. All right, I'm going to subtract 20 on both sides. I get 7x is equal to negative 56. Divide by that 7, and I get x equals negative 8. And that is our final answer. I do want to point out that the homework does ask you what is the LCD. Just remember your LCD is the same thing as your LCM, LCD, and so therefore your LCD is going to be equal to 4x for this particular example. It's just whatever your denominator is. All right, so let's do one more. So if you look at the B on the left-hand side, you'll see it's very similar to what we've been dealing with. It's very important that you put your parentheses around that x plus 1 because it's not just an x, it's not just 1, it's x plus 1, it's a unit. So we can see that this fraction with the x plus 1 is actually missing the 2x. What you do to the bottom, you do to the top. The next fraction, though, is missing the x plus 1. So I'm going to put that top and bottom, and I'm going to do the exact same thing with my third fraction because it is also missing that x plus 1. So I'm going to rewrite this. It'll say 2 times 2 is 6, x times x is x squared, minus, because that's what this minus sign is right here, 5 times x plus 1, all of that over my LCM, which is 2x times x plus 1. That is equivalent to my 3 times x plus 1 over my LCM, which I'm not going to write again because I don't feel like it. All right, so I have a lot of things happening, but because my LCMs are the same, I can go ahead and take my numerator and just work with that. So it's going to say 6x squared minus 5 times x plus 1 is equal to 3 times x plus 1. All right, I've got the distributive property, so that'll give me negative 5x minus 5 is equal to 3x plus 3. I have x squared on the left-hand side, so all my numbers need to go this way. So this cancels out, oops, not plus, minus 3. There we go. And this is going to give me, and I'm actually going to put this up here because I'm running out of space. This is going to give me 6x squared minus 8x minus 8. Okay, so before I continue on with this one, I can actually factor out a GCF. That gives me 3x squared minus 4x minus 4. And unfortunately, if I look at just my trinomial left, I still have a number in front of x. So I'm going to have to take that 3, carry it to the end, and multiply to do my slide and divide method. So it's going to say 2 times x squared minus 4x minus 12, because 3 times 4 is 12. Factor it like normal, so we should have negative 6 and positive 2. And then once we're done, because we slid and multiply, we are going to have to divide that 3 out. Remember, it's a 3 because that's what we multiplied by. If it works out to be a beautiful number, then yay, 6 divided by 3 is 2. But if it gives me a fraction, just make sure to reduce and then put your denominator in front. So it'd be 3x plus 2. All right, now to find my solutions, because these are not my solutions, these are actually my factors. So again, each piece is set equal to 0. X minus 2 is equal to 0. And I'm not going to be doing this example, so I'm going to use this space. 3x plus 2 is equal to 0. This doesn't have an x, so I can just ignore it. It doesn't really cancel out, but it doesn't give me anything. If I bring this negative 2 over, I have to do that by addition, so that's why I have a positive 2 now. And then I'm going to have to do a little bit of work with this 3x plus 2, but that's okay. Subtract that 2, we get 3x is equal to negative 2. Divide by the 3. That gives me a fraction of negative 2/3. So my answer or my solutions are going to be 2 and negative 2/3. And again, none of these are extraneous. You would have to plug it back in, but they don't cause any sort of issues. All right, so let's do the last one, which is letter C at the very bottom on the left-hand side. Again, same idea. Before we get started, I need to make sure I factor everything so I can see clearly what I have. Right here, I have x squared minus 9. That's a difference of squares. So that's going to be factored into x plus 3, x minus 3. So I have x minus 3 in the first fraction, but I'm actually missing the x plus 3. What you do to the bottom, you do to the top. The last fraction has the x plus 3, but it's missing the x minus 3. What you do to the bottom, you do to the top. So if I were to rewrite this, it's going to say 6 times x plus 3 equals 8x squared, and I didn't do anything with the center fraction because it had all the things already, so I'm just going to leave it as is. I'm going to carry that minus sign over. 4x times x minus 3. And remember, it's going to be over that LCM of x plus 3, x minus 3 over, and I'm not going to do it again, so it's just my LCM, but I will highlight them so that I remember that they are equally to each other. I don't really need anything else, so I'm just going to use my numerator. I have the distributive property right here, so that'll give me 6x plus 18 equals 8x squared, and then I have the distributive property here, negative 4x squared plus 12x. All right, I have x squared on the right-hand side, so I'm going to move everything over to that side. So I'm going to subtract 6, subtract 6x, subtract 18. It does not have any like terms, so we're just going to stick it at the end. Everything cancels on the left-hand side, and it should say 0 equals. Actually, I can combine like terms right here. This will give me 4x squared plus 6x minus 18. I see that I have a GCF, so I'm going to factor that out. That gives me 2x squared plus 3x minus 9. And now I have the exact same situation as I had before. I have this, this number in front of x, so I'm going to carry it to the end and multiply. All right, so I'm going to actually erase this for a second so I have a little bit of room. I'm going to take this and start working up here. This will be, if I multiply the 2 and the 9, which is what I'm supposed to do, it'll say 2 times x squared plus 3x minus 18. I'm going to multiply, or not multiply, I'm going to factor, and I'm going to get x, looks like 3 and 6 is going to work, positive 6, negative 3, and remember, when you do your slide and divide, you have to divide by what you moved, and I moved a 2 this time, so I have to divide by 2. So this is going to give me 2 times x plus 3. That worked out perfectly. But remember, if it doesn't, you put that denominator in front. And so this is our factors, but not our answer. Each piece is going to be set equal to 0, and you should get negative 3 and a positive 3 over 2. And this is our answer. Actually, we do have one extraneous solution here. We can't actually have 3. And an easy way to check that is if I go back over to my original equation, I have this x minus 3 in the denominator. If I plug in, so if I do that, let me do that off to the side. If I do negative 3 plus 3, it actually is going to equal a 0 in the denominator, and you currently do not know how to deal with that. So we are not allowed to do that, and that's why that negative 3 is extraneous. All right, hope that helped. Again, if you have any questions, make sure you email me.